Let's take a look at another kind of transformation called a translation. Now, sometimes a translation is referred to as a slide. And I think you'll see why in a second. We're basically taking a shape and we are sliding it across the plane to a new location. We're not turning it, we're not flipping it, we're just sliding it straight over to a new location. So, what we're basically doing is we're moving every point that's in our shape, or every point that's in our figure, in the same direction, the same distance, right? So if I think about that, I'm moving it diagonal. If I look at where A was and where A prime ends up, I'm moving it a certain amount to the left, and I'm moving it a certain amount down. And that resulting movement is kind of in a diagonal direction, right? But really, I'm moving a certain amount over and then a certain amount down. And that's kind of the way that we describe a translation, is we describe a translation that moves every point x units along the x-axis, meaning x units in some direction, either in the negative direction or in the positive direction along the x-axis, meaning horizontally, and y units along the y-axis, so the up and down movement, can be written as the translation of x comma y of shape triangle ABC to triangle A prime, B prime, C prime. And the translation will have the following properties. If I connect every point to its image, so the pre-image A to the image A prime, and I do the same thing for B and the same thing for C, then I've created these three segments, A prime, B prime, and C prime. I'll just kind of outline those a little bit in yellow. So I got these three yellow segments right here, A prime, B prime, and then C prime. Now those three segments have two important qualities. They're all parallel to each other, and they're all congruent. They're all the same length, right? And then it says here the shapes have, the original shape and the image have the same orientation, meaning it hasn't rotated, hasn't turned in any way. And a translation is a rigid motion, so the length and angle measure are preserved. Now let's take a look at this and let's fill in this generic x and y. Let's talk about what this translation here would be doing. If I look at this translation, I notice that to get from A to A prime, I have to go over to the left 4 units, or I subtract 4 because I'm moving to the left, and I go down by 6, so I subtract 6. So this translation, and I'm doing it for every point, right? B goes over 4 and then down 6, right? Over 4, down 6. C went over 4 and then down 6. Over 4 and then down 6. So my translation here would be, you could describe it as a translation of -4, -6 of shape triangle ABC, and that moved it to the new image triangle A prime, B prime, C prime. Now for this first example, we are going to try and graph, or try and place, the triangle EFG at its new location, its image, triangle E prime, F prime, G prime, using this translation. So capital T for translation of 7, -4 of my triangle EFG here. So this 7 and this -4, what that tells me is that I am going to be taking my shape and going to the right 7 units because it's a positive 7, and then I'm going to go down by 4 units. So if I start with E, I need to go right 7. So that's 1, 2, 3, 4, 5, 6, 7, and then go down 1, 2, 3, 4. So my new location for E, or E prime, is going to be right there. Now, let's think about the coordinates of E and the coordinate of E prime. The coordinates of E was at -5, 4. The coordinate of E prime is 2, 0. Now what do you notice? I notice that if I take -5 and I add 7, I get to +2. And if I take 4 and subtract 4, I get to 0. It's an interesting relationship, right? Well, let's go ahead and map out the other two vertices of my triangle, F and G, and we're going to do it using the same movement. So I'm going to go right 7, so that's going to go 1, 2, 3, 4, 5, 6, 7, and then down 1, 2, 3, 4. So now my new location for F is right here at 6, comma 1, and it was at -1, 5. G, which has a location of -2, -1, is going to move right 7, so it's going to move over to here, and then down 4. It's going to be right here now at 5, comma, negative, 5, comma, did I go down? I did 5, comma, -5. So now if I connect all my points, I'll have, let's do the connection in purple here. Then if I connect all my points, I have my new triangle here. Triangle E prime, F prime, G prime. One other thing I want to take a look at is if I connect all of the original points to their images, right? So I'll connect them. There's E connected to E prime, here's F connected to F prime, and here's G connected to G prime. Those three segments, again, they follow the rules that they are parallel to each other, they all have the same slope, and they are all the same length. They're all congruent to each other. For the second video, we are given an image, a pre-image, STUV, this quadrilateral in black, and the new image, S prime, T prime, U prime, V prime, the quadrilateral in red, and our job is to write the translation rule, right? So we are going to write the rule, so we're looking at saying translation of blank, comma, blank of the shape STUV onto the new shape S prime, T prime, U prime, V prime. And our job is to fill in these two blanks with what horizontal movement and what vertical movement we did to each of these vertices to get them to their new location. So this isn't actually too bad. Let's start at S. If I want to go from S here to S prime here, I need to go backwards 1 and down 4. So that would be -1 and -4. If I went from T to T prime, I go backwards 1 and down 4. If I go from V to V prime, it's backwards 1 and down 4. And if I go from, let me get a new color here. If I go from U to U prime, it's backwards 1 and down 4. So every time our horizontal movement, our X movement is is backwards 1 or left 1, and our vertical movement, our Y movement, is -4. So to fill in these numbers here in the translation rule, it's going to be a -1 and a -4. So our translation rule then would say the translation of -1, -4, or -1, -4 of the shape STUV results in the shape S prime, T prime, U prime, V prime.